This movie is about class diagrams. We've already looked at the basic notation that you're most likely to need, but there are a few pieces of notation that are used less often, but worth knowing about, even if it's just so that you understand what they mean when you see them. First, I'm going to say a little about modelling at different levels and the different amount of detail required. Then I'll summarise some of the additional things you'll see on associations, talk about interfaces and enumerations, and say a little about structure inside a class, using what's known as a composite structure diagram. You may produce class diagrams and other diagrams for that matter for different purposes, and typically these different purposes involve different levels of detail. At the lowest level of detail and most abstract, you might produce domain diagrams that focus on the business objects used in your organisation. Often such class diagrams don't include operations, but provide a high-level view of data across the business. Diagrams like these are likely to be used as architectural artifacts or for governance purposes. Within specific application projects, you're likely to be working in more detail. This could be specifying the business objects that are required as part of the procurement exercise for purchasing a commercial off-the-shelf product, or it could be as part of a project to analyse, design and build a new system for your organisation, whether the development is done in-house or outsourced to a supplier. In some cases, you may be working as a developer on a project, writing code, or using the capabilities of a modelling tool to generate code from the model. In this case, the model will need to have the most detail, reflecting features of the programming language. The important thing with modelling is to model with a purpose. Don't produce models or diagrams for the sake of it. They need to provide some value to the organisation or project. And don't use unnecessary features or detail if they're not required. We've already seen that associations can have names, multiplicity, role names, and navigability. A couple of other pieces of notation that you may see or use are the dot on the association here that shows that it's owned by the class at the other end, and the constraint in braces. In some cases, an association may have data associated with it that doesn't belong to either of the classes at the ends of the association. In this case, an association class can be joined to the association and specified with the necessary attributes. If you program in a language like Java or C#, you'll have come across interfaces, which specify a set of operations that must be implemented by classes that realize the interface. UML provides a notation for showing interfaces and the realization relationships, which in Java, for example, would be represented by the keyword implements, as opposed to extends, which is used for inheritance. Enumerations are used to create lists of values for types that we want to use in the system. Device state and device action, which have been mentioned in other movies, are examples of types that could be implemented using enumerations. The diagram here shows the two kinds of event, both realizing the activatable interface and having an association with the enumeration device action, which defines a list of permitted actions. Finally, we sometimes want to show internal structure in a class. This would be the case particularly with inner classes in some programming languages. However, we could use this approach to show the composition of schedule containing an array or collection of timed events as a property rather than as an attribute as we had it before. This is technically known as a composite structure diagram. You're less likely to need these pieces of notation, but we'll look at them in more detail in the following movies.